Can you tell us a bit more about, as I understand it, there are two aspects, to oversimplify things dramatically, two aspects to your technology in a big picture sense. One is the renewable, the recycling aspect of your technology, which is on obviously the far side of the process where you're finished with the battery and what happens to the battery after that. But you've also got something at the beginning of the process, which is the extraction process itself for extracting lithium from the environment around us. I'd like to know a bit more about each of those technologies and how they relate. So starting first with the recycling technology, can you tell us what makes American Battery's technology different from the processes that are out there already that relate to recycling?
Yes, of course. And like you mentioned, there's a beginning of a process, usually there's the end of a process, but because we're creating a closed loop economy, we have on both sides of it. So we are receiving the end of life material and we are producing the new battery metals to go back into new battery cells themselves. So it doesn't end up being a beginning and an end. This really just closes the loop to make these battery metals be used indefinitely. On the recycling front, what we really do differently is many processes today really just use what were designed to be, scrap metal and stainless steel recycling systems. They start off with, very high temperature melting furnaces where they simply melt all the material together. And when you have aluminum or scrap metal, that works rather well. But when you mix batteries in, there are many elemental materials within the battery cell that become very toxic when they're taken at high temperature like that, such as fluorine and phosphorus and sulfur elements really get turned into this toxic air emission. You get particulates of heavy metals that are released in the air as well, and many of those materials end up going in large amounts of water emissions. So you either have to allow those materials to go out as contaminants, or you need to spend on costly systems to then have them removed again from the air and water emissions. And when you do that, there are high value materials in batteries like cobalt and nickel and lithium, but there are many low value materials like iron and aluminum and mixed plastics. And when you simply melt everything together, it then makes it very difficult to separate out the high value from the low value materials. So it really hurts your recovery efficiency. It results in a much larger environmental impact, and it's more costly. So again, in my background and much of the team I brought on here the past year, we were some of the initial designers of, the largest battery factory in the world, the Tesla Gigafactory outside of Reno. So we started back in early 2015 and really started when the factory was a patch of dirt out in the desert. And we're part of every part of the design of that facility, the startup of the systems, the commissioning, and the troubleshooting of many of those production lines. And really from learning how batteries are made from a fundamental manufacturing side, how they go from powders to slurries to coated electrodes to dry and press systems to rolls to cells to modules to packs. So instead of actually just melting everything together, we've used that skill set to design what we call a demanufacturing process, where we essentially back out each of those operations in a very automated and high-speed fashion that allows us to get back to separated metals and powders within a matter of minutes without a large amount of labor and while really preserving the separation of those high and low-value materials. And then once we have that high-value powder separated out from the rest of the low-value materials, that's where we use a custom chemical extraction train that we've developed. And these types of chemical extraction processes can also have large environmental impacts if not done correctly. They can consume large amounts of acids and bases, use very large amounts of solvents and oxidizers. And by removing so many of those low-value materials upfront mechanically, we're able to use a much more targeted and simpler chemical extraction train for these high-value materials. We've also developed a system where we can actually generate our own acid and base and reagents on site ourselves instead of buying from the open market, where again, those second and third tier emissions are very large for how acids and bases are manufactured today. So by having this automated high-speed system at the front end, where we have absolutely no high temperature operations, even our process heat and our space heat is generated by waste heat recovery and electric heat pumps. We have no combustion anywhere on site. We have near zero air emissions. We've developed a closed loop water system, so no hazardous liquid water discharge. And by upgrading these materials all the way to these rigorous battery cathode quality, every time we sell a recycled battery metal to the market, it displaces the mining of a primary material. And some of the most polluted places in the world are nickel and copper mines. And every time, again, we go through this recycling process, much of our environmental benefit is displacing the need for those very polluting technologies.